Hi folks, we're going to take a look at question 6b from page 139. So they give us a function and they want us to find the derivative of this function at a particular x value, in this case here 64. So recall that in the past what we would have had to do would be to use the limit definition for the derivative or rate of change at a point and use this function and that point and solve a limit. But now with our derivative properties we don't need to do that. Okay. First thing I notice here is I've got some additions and subtractions, so I can definitely split them up into smaller components using the addition and subtraction rules. I also have these constant multiples, so I don't have to worry about those. I can just find the derivative of the variable term and then multiply it by 6 and here multiplied by 5. The only thing I'd like to change is I'd like to have this in a more user-friendly form. In other words, something that looks like x to the n, because we know how to determine the derivative of that function. Okay, so first thing I'll do is I'll change the form here. So 7 minus 6 times x to the 1/2 plus 5 times x to the 2/3. Okay, now I have it in a form for which I can find the derivative. So let's find the derivative function of f. So notice here, first I have to find the derivative function. Once I have the derivative function, I can then input my x value into that function. Okay, so here the derivative of a constant is just 0, so that's nice and easy. Here minus 6 is just a constant, times, now I'm going to find the derivative of x to the 1/2. So recall how that works. When you have x to the n, the exponent comes down and becomes your coefficient. So 1/2 times x, and your new exponent is 1 less than the previous one. So 1/2 minus 1 is negative 1/2. Okay, and then plus 5, just a constant times another function. So I can now find the derivative of x to the 2/3, and similarly we have 2/3 becoming the coefficient, and then the exponent decreasing by 1. So 2/3 by minus 1 is negative 1/3. Okay, so let's simplify this here. So we've got 6 times 1/2, so we just have our negative 6 times 1/2, so negative 3. And then here we've got 1 over x to the 1/2, or 1 over root x. Okay, and then plus 5 times 2/3 is 10/3. And then here we've got, again, because of the negative 1 over, and 1/3 represents cube root of x. And so now we have our derivative function. So we can determine the rate of change, or the derivative of f, at 64 by inputting this into the derivative function, which is what I'm going to do now. So f prime 64 gives me negative 3 times 1 over the square root of 64 plus 10 over 3 times 1 over the cube root of 64. And luckily these work out quite nicely, so square root of 64 is 8, so negative 3 over 8, and here we've got cube root of 64 is equal to 4, so I'm left with 10 over 4 times 3 is 12. Okay, so here let's add these up. So we'll use I guess a common denominator of 24, so multiply both by 3, so we have negative 9 over 24, and here we have multiply both by 2, 20 over 24, and negative 9 plus 20 is 11 over 24. Okay, and there we go. There's our final answer. So just a recap. Okay, you're given a function. You need to find the rate of change at a particular point. The first thing you do is to find the derivative function, and then you can input your particular x value. Okay, that's it.